Our next method of solving quadratic equations will be through a process called completing the square. Now, in order to complete the square, you need to be very familiar with perfect square trinomials. So, just go back and kind of refresh your memory on a perfect square trinomial a little bit. If you recall, a perfect square trinomial is a trinomial that could be broken down into two perfect squares, so x plus 2 and x plus 2 in this case, and since they're the same, we can write them in what we call a binomial squared. Now, this perfect square trinomial has this very specific pattern that goes along with it. And so what we're going to do is to try to show you a process in which you can create and develop that pattern. Now, just give you a quick example. If I gave you x squared plus 6x and I wanted you to fill in the blank so as that we had a perfect square trinomial. Now I'm just going to leave these areas blank for right now. We're trying to create a perfect square trinomial with x squared plus 6x, and then what do we need to add to that? If you recall that whatever two values we need here in the highlighted areas, they have to be the exact same thing for it to be a perfect square trinomial. So they have to multiply to get that number. So we got to think of two things that multiply together to get a number, so they are squared. And they also have to add up to get the middle term. And so if we think about this backwards a little bit, you could say what two numbers actually that are the same add up to 6. And so if we're looking at all the values that add up to 6, we've got 5 plus 1, we've got 4 plus 2, we've got 3 plus 3, and of course you don't want to forget about 6 plus 0. And we're looking for the two numbers that actually add up to 6. So I'm actually going to kind of back my way into this. So you can see I'm going to have a 3 here and a 3 here. And 3 plus 3 gives me 6. But if we were to FOIL these together, the 3 plus 3 would actually give me a 9. And so the 9 is the value that would actually create this perfect square trinomial. Now, if we look at a different problem, we may be able to see just a little bit more clearly what we're dealing with here. If I have x squared plus 5x plus blank, and I need to figure out what two numbers add together to give me that 5. So I need two numbers here that add together to give me that 5. And keep in mind, those numbers have to be the exact same number. Well, you can see very clearly that we're not going to have two numbers that are exactly the same unless we go into decimals or fractions. And so many of you may be thinking to yourself, oh, what about 2.5 plus 2.5? And that's absolutely correct. However, what I would like you to do is think of this as improper fractions. So 2.5 is the same thing as 5 halves. So we're going to say 5 halves and 5 halves, which is there. Now, if we need to know what that number is that we're going to add to make this a perfect square trinomial, it's actually 5 halves times 5 halves, which is going to give us 25 over 4. And I know this can look a little funny, but x squared plus 5x plus 25 over 4 actually is a perfect square trinomial. Now what I want you to recognize right here before we get into notes is look at this relationship between here and there. That b value is being written over 2, and then it's being squared to get the 25 over 4. So if you think about this, if we took 6 and wrote it over 2, that would give us 3, and then of course the 3 squared would be 9. And so we can come up with a little pattern here that if we take our b value, write it over 2, and we square it, that's going to equal the c value that we're trying to use to complete the square. Now, if we go back to the notes, you can see this process in a visual nature, and you can see clearly why we call it completing the square. if I take the b value over 2 and I square it, it completes this square, this visual square that we've created with the x's and the b value. So if we give you a b value, we should be able to use that to complete the square using the formula for c equals b over 2 squared. So let's take a look at an example problem. You can see here we were given x squared minus 7x plus c, and we were trying to find that c. And of course, we just simply gave you a formula for that, and you could just plug it in. Now, it's very important for what we're going to be doing later that you write this as a binomial squared. So you would say x minus 7 over 2 squared. So let's try to work a problem on our own. Let's go down here. Sample problem number 1. It says find the value of c that makes x squared minus 3x plus c a perfect square trinomial. So take a second to draw that. Okay. Now, basically what we were trying to do is what we were trying to do on the previous page. We're trying to find the number that makes this a perfect square trinomial. Now, notice here that this is a negative number, so these two values also have to be negative, and that makes the binomial negative. However, we still follow the same process. Two numbers that add together give us 3, and so in this case we're going to be having a decimal or a fraction, so this is our b value over 2, which is this value. But in order to get that perfect square trinomial, we need to square this. And so that's going to equal to 9 over 4. So 9 over 4 is the c value that makes this a perfect square trinomial. Now, make sure you practice this process a little bit. Of course, put negative here if you want to do that. Practice this a bit. We're going to be using this process to solve quadratic equations in the next part of the notes.